as you can see on both computers, the ping is timing out, meaning the network has gone down. And Wireshark is showing that somebody is tearing down the network with ARP spoofing. And then finally, yeah, Google cannot be accessed anymore. And that's it for the second demo. And we're gonna go back to the first demo because our guy seems to have fixed the wireless issues. So this is a Nintendo DS, and we're gonna run the meta D-exploit, D standing for the DS. And searching for the IP time router. And connecting. Hope it works this time. No? Come on. Okay, we'll just move on to the third demo because the wireless seems to be used by so many people in this room that it's not quite working as it's supposed to. So,
You're holding it wrong.
뭐야 이거? 형이 거꾸로잖아. 아, 짜증나. Okay. This time we're going to show malicious code injecting into network packets using ARP spoofing. So you see a typical computer. What the? Okay, I'm really sorry about this. 아 뭐예요? 아 진짜. 영상에 영상 처리에 상하 반전하는 거 있었잖아요. 그거 못해요?
그래 전체 버튼인데 전체 버튼 안 먹혀.
오른쪽 버튼 안 먹혀요? 영상에 영상 처리에 상하 반전. Okay. And you see a typical computer connected to a home network. And we're connecting to Google to see that there's nothing wrong with the network. And And yeah. The Google page doesn't look like that, however. It's a custom page we created for testing purposes. What?
좌우가 바뀌었잖아요. 맞지? 맞지?
네. Okay. Finally. And this is a custom Google page that we created. And opening up Wireshark now to monitor the packets. Now we're going to run the inject frame homebrew. What it does is insert an iframe in a page by modifying the packets. So connecting to an access point now, and we're going to set the IP of the DS manually because there's a glitch in the homebrew that we didn't manage to fix, but it's just a little extra work. So writing down the subnet mask and gateway and connect it, and seems like the attack just started. And looking at the packets, we can see that tons of ARP packets are being sent by the homebrew. And these packets make the host think that the DS is a gateway and make all the traffic go through the DS. And the DS modifies these packets and resends it to the hosts. So when you look at the Google source code again, nothing's changed because of the DNS cache. So we're going to refresh it now to reflect the changes. And then we see that a new iframe code is injected in the page. The iframe page will consequently load a malicious page created by the malware author. And that's about it for the Nintendo DS.
다음으로 어떻게 넘어가요?
And then now, that's it for the Nintendo DS, and now we'll talk about malware on gaming consoles. And we particularly targeted the system Nintendo Wii, and the reason is that as you can see on the picture on the left side, Wii is marked as the second most pirated system among all gaming consoles, and also according to a survey, a lot of companies put Nintendo Wii in their break room to increase morale. And I don't exactly know why Nintendo Wii would increase morale more than Xbox or PS3, but I've seen a lot of Nintendo Wiis myself at a couple companies I visited, so we decided to give it a shot. And now that we have the target system, we should know how games work on the Wii. And all games contain a single file with a .dol extension, which you can think of as a main executable file. And this dol file contains all the code needed to run the game. And according to the file format, it's essentially a stripped down version of an ELF file with the non-important data, such as debugging data and compiler-specific data, all stripped out. So when you actually play the game, the execution goes from the system menu, and the system menu being the first screen where you see a lot of selection boxes, and to the app loader, which does all the initialization stuff, and finally to the actual game. And like I said, the .dol file contains all the code needed for the game to run. So that file must be the most interesting one for our purposes. So how exactly would a malware be injected? Since we know that a DOL file is basically an ELF file, it seems that the techniques used in ELF malware can be used. But the thing is, calling the internal we functions is not as simple as using a couple system calls, and there really isn't such thing as imported functions in we executables. They're pretty much just statically linked into the binary. So we decided to use a different kind of approach. What we did was statically compile all the library code in our homebrew application, which is done by default anyway, and fix the image base to some place in the game memory that's not occupied. And after that, attach our homebrew application to the game app executable and fix the header in the game DOL file to reflect the changes. And the entry point will be changed to the entry point of the homebrew. And after the homebrew finishes running, the execution will be transferred to the game, which requires a small jump patch in the executable code. And there's also a place in the homebrew that causes problems. So after making those last fixes, all you have to do is pack it back neatly into a game ISO file and distribute it to the public using torrents or POP or whatever you like. And there's a small tool I made that semi-automates the injection process, and I'm not trying to give you like a full walkthrough of how to create we malware, but just to give you guys an idea of how it works, I'll show you a little demo. First, you have to extract all the files out of the game ISO file, which I won't show you because it takes more than 5 or 10 minutes. And my favorite tool for that purpose is WIT, and this is the extracted game image, which is Okami extracted. We use Okami here for the example, and normally the main DOL file is at the sys folder, so finding that main DOL and copying to the injector tool directory right now. Yeah, and you can see that main.dol file right there, and that has all the game code in it, so we're gonna copy it. Well, it's already copied to the injector directory, so moving on to the injector. The injector needs 3 files and 3 addresses to work correctly. So, and these addresses can be found in IDA. So we fire up IDA and load up the homebrew. And this is the assembly code of the, just a sec, executable code of the homebrew file. And I'm going to skip all the analyzing part, and this address right at this part, this is a branch instruction, and that branch is the last branch taken before the system completely shuts down. So we're going to use that branch as a trampoline to the gaming, to the actual game DOL file. So that's going to be the first address.